would we solve these quadratics? What do you think we would do here? Yeah, we're going to have to subtract that 50x. We said one of the main things we have to make sure we do is we have to put everything on the same side. So if we're going to move this over, now we have 16x squared minus 50x plus 25. That equals our 0, right? Remember, y is 0, so that's an x-intercept, a 0, a solution, a root. And how are we going to find then what the rocks are here? Can we graph this? Let's do that. So this was our first root. On the second one, we said, again, move this over so it becomes a positive. And when you graph it, make sure you use x's, not w's. And we had negative 14 and positive 8. Remember, you can write them as coordinates. However, you can also write them with the braces. So we're going to look today at graphing and writing those factors and using those linear factors to find our roots. So we have a quadratic equation here, x squared plus 2x minus 3. And the factored form, so how did they do the factored form? Well, they did the box. So if we review box really quick, we said A goes here, C goes here. Notice C is negative, so we have a positive and a negative, right? And then we said A is 1. So 1 times 3, that's that whole AC piece. Well, the only factors of 3 are 1 and 3. And if I need a positive 2 is my 3 or my 1 positive or negative? Which one is going to be positive if I need a positive 2? Is it 1 minus 3 or is it negative 1 plus 3? If I need a positive, my bigger number needs to be positive. And then we talked about way back, we talked about you can take out a GCF. X times negative 1 is negative 1x. X times 3 is 3x. So that's where they got, so here's our linear factors. Okay, so that's how they got that. You guys have done that. Graph the factors independently on the graph. So these are called linear factors because, right? They are our factors. They're things we multiply to get that answer. And linear factors are factors created by graphing the x equals form of a quadratic as two linear equations. Okay, so let's talk about what that means. They share the same shape or roots, excuse me, as the original equation. Okay, so what we're saying here is you got to get these factors. And remember, it's going to be set equal to 0, right? F of x is always going to be equal to 0. Okay, so we're going to set both of those factors equal to 0. So let me go back up so you can see what I'm talking about. I don't like the way those notes are set up. So if I said x plus 3 equals 0, how do I get x by itself? Think about this is a 6th grade problem, right? Don't overthink it. How do I get x by itself? How do I move the 3 away? What do? I subtract 3. So x equals negative 3. Oh, look. Does it match? What about if I did x minus 1? How do I get x by itself? I add the 1. X equals 1. Oh, look, there we go. So our linear factors are going to give us what our roots are. Okay? Now, when we graph and we get our roots, we can work backwards to get our factors. So there's a couple ways you can do this. We can write our factors, our roots. So we had x equals negative 3, and we had x equals 1. And if we want to write it as a factor, okay, Remember, factors are going to be x plus or minus some number, x plus or minus some number, right? So I need to move my 3 back with the x. How do I move my 3 back over? How do I put my 3 on the same side as the x? I add it. I get x plus 3. Was that one of our factors? How do I move my 1 back over? I'm going to minus it. So you have to realize a couple of things. I want you to notice that when we do that, the signs of our roots, they change, right? Our factors are plus and minus, and then when we got our roots, they were a minus and a plus, okay? All right, so we have Desmos open. Things I need you to remember. If we're going to graph this, everything has to be on the same side. So what is this new equation going to be? We're going to make that p and x, right? 4x squared plus 20x. What's that 24 become? Minus 24. So now we're going to graph it. We're going to put this in Desmos, and we're going to get x equals something for the roots. So let's do that just like we did in our warm-up. So we got x equals -6 and x equals +1. These are our roots, our x-intercepts, our solutions, our zeros. If I want to write my factors, remember, factor means multiply, okay? That means my everything now needs to be on the same side. So what am I going to do to move this -6 over? What's the opposite of -6? +6. So what do I get? My first factor is x plus 6. What about this 1? How do I move it over? It's a positive, so we're going to make it a minus, x minus 1. And these are our factors. Okay? I do want you to realize that if this was a multiple choice question and they just gave you this equation and you moved the 24 over and you got x equals -6 and x equals +1, if they were asking you for the factors, do you think one of the answer choices might be x minus 6 and x plus 1? Yes. Okay, so you have to remember that when we go from the roots to the factors, because again, we're crossing that equals, we have to change the sign. Okay? So let's try another one. Let's try this one. What do we need to do first? In order to graph it, what do we need to do? Yeah, we're going to add the 2x. Very nice. So now I have x squared plus 2x minus 15. Put that in your Desmos. And let's get our roots, our zeros, our x-intercepts, our solutions. So we got x equals -5 and x equals +3. Those are our roots. Make sure you know the difference between our roots, our zeros, our x-intercepts, our solutions, and our factors, okay? Factors, again, mean multiply. Everything needs to be on the same side. So if I'm going to move this -5 onto the same side, what am I going to do? We're going to add it. Good. So what's my factor? X plus 5. What am I going to do with this 3? We're going to subtract it. What's my factor? X minus 3. Okay, and could we technically check this? Could we graph in Desmos on our same graph, x plus 5 parentheses and then parentheses x minus 3? Should it overlap and give us those same roots? Yes, so you can check yourself doing this. All right, this should be our last one. Oh, look how nice that's already nice and pretty all on the same side. So I want you to graph this for me, please. Graph this in Desmos and tell me what the roots are. 16 minus 50 plus 25. So we got 5/8 and 5/2. Okay, so these are our rocks. Let's make sure we're labeling those. Now, we still need to move everything over to the same side, okay? Do we remember how to get rid of a denominator? This 8 on the bottom, this 2 on the bottom, those are our denominators. They are down because they are dividing. So what is the opposite of dividing? To multiply, right? Do you remember us doing this before? So we're going to multiply by 8. Well, 8 times x is just 8x. And if you're not sure about 8 times 5/8, you can use your calculator. 8 times 5/8 is just 5 because we're getting rid of that denominator. That's why we're multiplying by it. Now, we can move our 5 over because we want everything on the same side. Everything on the same side. How do I move that 5 over? It's a positive, so we're gonna subtract it. Ooh, okay, so this one's a trickier one. We have 8x minus 5. That's one of our factors. And then what are we gonna do with this 5/2? How do we get rid of that one? What do we do with the denominator? We have to multiply. What are we multiplying by? What's my denominator? 2. Good. So we have 2x equals 5, right? The whole point in multiplying by the denominator is that it's going to make that denominator go away, right? And then how do I move this 5 over? It is a positive, so we're going to subtract again. So what is my other factor? 2x minus 5. These are our factors. Okay? These in red, these are our roots. Our zeros, our x-intercepts, our solutions. So we graphed it. You can see it is the red one. So for that first one, our roots are going to be 0.625 and 2.5. So when we look at that second one, the 6w is on the wrong side and it's a negative, so we're going to have to add it. Now when you graph that, you don't want to use the w. You want to change it to an x. So you can see here mine is blue, -14, and +8. So for this third example, we did get some decimals, but we put the decimals underneath our equation and we changed them to fractions. So when we write those roots, we want to write them as fractions. So we're going to write them as 5/8 and 5/2.